Hey guys, welcome to physics. I sent you this grounding PowerPoint. It's just a couple slides on grounding, which was the last thing that we were going to touch on before the exam. I talked about it briefly, but I wasn't able to get into it. This is just kind of a summary slide as to what grounding is. The overall idea of grounding is to make things safer. Um, so outlets in your house are grounded, buildings are grounded. Um, you're going to see something later on where trucks have metal chains on them to ground them. It's basically a way to release excess electrons or static charge buildup. It's a way to release them into literally the ground, like the earth. So, for example, let's just say a building that you're in gets, struck by lightning. Well, you do not want that massive amount of charge to be in that building. Well, why? Well, conductors allow the flow of electricity, which means that all the conductors in that building, if you touch them, you could get zapped pretty seriously. So, buildings are grounded, which means that they have literally a ground, a pipe, something metal that is stuck to the building, and then it's literally dug into the ground. So that way those electrons have a pathway to be safely released so that nobody inside can get hurt. So grounding a charged object makes it neutral. That's very, very important, especially with lightning strikes. And we're going to talk about the truck thing that I had mentioned in a few slides. So this is just a summary slide. There's nothing to write here. Well, how does it occur? Well, an example here is that they're giving you is, let's just say you have a positively charged metal ball. Well, what likes positives? Well, negatives, of course. So electrons are going to flow towards that positive object. So electrons are going to flow from the hand to the metal ball, and what's going to happen is those negatives and positives are going to balance out and neutralize. So when they neutralize, that metal ball is going to become a neutral object. Okay, well, what if that metal ball was negative? Well, negative things don't like negative things, right? But what's going to happen is the electrons inside that metal ball are going to see your hand as a more positive place. So what they're going to want to do is, instead of electrons flowing from your hand to that ball, like in that first example, the electrons are going to flow from that metal ball into your hand. So extra electrons flow from the metal ball to the hand. Okay. And then what's going to happen is the extra electrons leave, but some electrons stick around because they still like the protons that are in that ball. So I don't want you to think that there aren't any protons in there just because they're not drawn in there. They are. And some electrons are going to stick around, but the extra ones that are there are going to say, see you later, and jump to your hand. So when they do that, the ball is going to become a neutral object. Okay. So it's all about balancing. Objects don't really like to have an overabundance of electrons. They want to be neutral. So that's why static charge, or you get a static shock if you touch something, that's why it happens. Okay. So I'm sure it's happened to you before, right? You go to wash your hands or what have you, and you touch the faucet and you get a zap. Okay. Well, you can't really tell who's or what object is charged with what charge, who's positive, who's negative. You can't really tell. All you know is that you just got a zap. However, in this example, if you were to count all the positives and negatives in the hand, you would see that the hand is negatively charged. Okay, and that faucet is neutral. There's an equal number of positives and negatives. Okay. So then when you bring your hand close enough, what's going to happen is those electrons in your hand are going to detect that faucet is a much more neutral space. So when the hand is close to the faucet, some electrons from the hand move toward the faucet and create an electric discharge. Okay. And sometimes, I mean, you don't even have to be touching it. It could happen before you touch it if there's enough of a buildup. And then, so after grounding, so that's grounding, when those electrons jump from your hand, your negative hand, to a more neutral space, it's grounded now. So after grounding, the hand loses its negative charge and the extra electrons go into, well, first they go into the faucet, but then they discharge into the earth. So first they go into the faucet, and then from there, they just go into the earth. Oops. Okay. So this is what I was talking about earlier. It says, why do gasoline tankers usually have metal chains in the back? You might not have noticed it. It's probably just a truck driving by and you're busy doing something else. But they have them there. It's intentional. It's for a reason. It's not that, somebody forgot to cut them off. Okay. So it says, when cars run, their tires and bodies are usually charged by friction. Because think about it. Your tires are rubbing on the ground. Okay, and that's charging by friction. And you can charge up an insulator, right? I was able to charge up that balloon with the rabbit fur. For gasoline tankers, if the accumulated charge is large enough, sparks can be produced. And an explosion will occur if gasoline vapor is ignited, which is not a good thing. Those metal chains conduct the charge on the bodies of the tankers to the ground, literally the cement, the earth, and avoid the danger. So basically what's happening is as these trucks are driving all those tires, and tanker trucks don't have just 4 tires like a car, they've got a ton of them. So it's really easy for buildup of electrons to happen, for static charge to happen. And unless those electrons are sent down into the earth with those chains, it could be a really, really dangerous situation. So that's why grounding is really important for gasoline tankers. It's important for buildings. It's important for things in your house. It's something that you might not have thought of before, but a buildup of electrons. I mean, you can feel what happens when you have a static charge buildup and you touch a light switch or you touch another person, right? It kind of hurts, but on a larger scale, it could be really, really dangerous.